Let's define the DNP3 Slave Protocol together. First, let's get the TCP socket block and the DNP3 slave block. Let's connect the output of the TCP socket block to the input of the DNP3 slave block. We selected the server option from TCP socket block as it acts as slave. And we define the listening port. I entered the default port as 20,000. You can define any port you want. Ethernet, GSM, or Wi-Fi can be selected from the media type options. Since we will be communicating over Ethernet in this application, I choose the Ethernet option. If we want, we can define the local address from the inside, or we can define it from the outside via a block. If unsolicited is enabled from DNP3 master, trigger input is sent with rising edge. Periodic transmission can be made whether or not there is a change in the variables defined in DNP3. In the application example, let's do the reading and command sending process together. Let's take the binary register block to read the data of a binary value. And we take the screen of the register block to read the values of word, float, and long variables according to the variable types. Let's add the binary word, float, and long register block for command transmissions. It will be activated in the enable input of the TCP socket block. So, I'm connecting a high gate. We will define the added blocks in the DNP3 protocol. We should define line labels to match variables in the variable address table. Normally, every block added to the project has default definitions. Let's give them names like word, float, long to make it easier to select them. Let's name the writing blocks again. We will need these line labels when we move the DNP3 protocol in a moment. To make the definitions, let's go to the variable address table from the project section, and we press Add. Static and event variation definitions are made in the DNP3 protocol. Object types are determined according to the selected variation values. You can access the variation information supported by the microdef from the application note with DNP3. This document includes object types supported for control and object types supported for reading. You can access this document from the video description. Static variations are read from the master with the integrity poll query, while the DNP3 slave device receives the instantaneous values of the defined variation. Event variations are values transmitted unsolicited from the DNP3 slave device or read by the master's class query. In the DNP3 protocol, variability can be categorized according to generation classes. When the master sends a class query, the slave device responds to the query according to the classes selected here. When defining variables in the DNP3 protocol, Static and event variation values and class value 0 should not be selected. First, let's define the binary register. The address table is a new table, so we started it from 0. You can define any address value you want. DNP3 is selected as the protocol type. When we come to the object type list, we select DNP3 object type binary input to read the value 0 to 1. We chose the value 1 for static variation, event variation, and class. Let's select the sending method as level change and leave the change value at 0. Here we select the line label as the binary read that we did for the binary register. You can update the definition you made here by clicking Update. Let's say Add again and Continue. This time, let's make a definition for the word value. Let's give it a name called word read. Let's say the address is 1 again. We go in order. As I said, you can sort the address however you want. The important thing is that the addresses do not conflict. Protocol type DNP3 is selected. Here, the object type analog input must be selected for word, float, and long registers. Here, the variations we choose determine whether it is long or float. Let's select static variation and event variation 2 for word value definition. We select object class 1. When we say Add and Continue, we can make definitions one after the other without closing the screen. Let's choose this option this time. Let's add one more. This one is for float values. Address I started from scratch. I am giving the addresses in order. You can give the address you want. When defining the address here, be careful not to overlap the addresses. Let's select the line label as analog read. This time the variation information will change. Let's select static and event variation 5 here. Object class can remain as 1. Let's keep it this way. Now, let's make a definition for the long value. Let's write the address as 3. Let's select the label for the long value by line label. DNP3 protocol must be selected. Again, the object type should remain as analog input. Here's static variation and event variation change. Let's select value 1 to read them as long value. Object class can remain as 1. Let's leave the level change at 0. Add and Continue. These were definitions from a reading perspective. Now, we will actually make definitions in terms of writing. Let's go in order here. Again, let's give a name like binary write for the binary value. Let's say the start of address is 4. This time, let's select the label we associated with. Binary write. Our protocol is DNP3 and our object type is 10 to send a binary value. We need to select the control relay object type. Static and event variation should be selected as 1. These are already 1. Object class can remain as 1. Let's continue. To send a command to a value in Word, let's give it a name, word write. Let's say its address is 5. Also, from the line label section, let's select the label that we will associate with word write. It will again be the DNP3 protocol. This time the object type must be control analog. We select the same object type for word, long, and float values. The determining factor here is the types of static and event variations. I choose 2 for the word value. It can remain as 1. Let's continue. Let's define in float value. Let's say its address is 6. Static variation and event variation. In this case, 5 different static variations must be selected. We can choose our event variation as 3. Again, DNP3 protocol, object type must be control analog. And finally, let's make a definition for the long value. Let's say its address is 7. I come to our line label. I choose long right. Our object type will be control analog. In this case, static variation and event variation 1 must be selected. Let's check. Let's fix the line label here. This line tag needs to be word red. Let's choose it. Let's choose it. Let's call it update. Here again, let's choose the correct address for analog right. We have made the definitions. I will take 2 register blocks. This is required to send the classes and device object. Let's define a register for the project. Let's call one of them class. The other line label should be device. Here I come to the variable address table again. I will make definitions in these 2 variables I wrote. Let's do it for class. We can start the start address from 10,000. What is important here is that you can enter a large number to avoid confusion with other address definitions. Let's select the class tag. It will be the DNP3 protocol. Here I find class. We need to select class object 60. We can select static event and class 1. Let's call it add. Now, let's do it for device. Let's say its address is 10,001. I select device for line definition. Our object type will be device object. This corresponds to 80. You can leave the static event and class variation as 1. When I say add, it is added. We have to define these 60 and 80 object types in order to send classes to the microdef DNP3 Slave Protocol. Finally, let's load the project to the device, and I got help from View Plus SCADA software to test. Unsolicited submissions on the master side. Let's do our tests as enable. I'm starting online monitoring. SCADA software and ARTU communicates via the DNP3 protocol. Here, a state of the binary register is displayed on the side. We can follow the blinking status via LED. I am sending a value. You see it is now green. When I send the 0 value, our LED is off. Now, let's set the value of the word register via ARTU. I enter a value like 70. It was passed here as unsolicited. Again, we can change the value and enter the value 80. When I send it, we see that the value is transmitted here. A common expression for float value. Let's say the value is 10.5. As you can see, the value of 10.5 is transmitted to SCADA as unsolicited. We can change the value again. Let's write 8.4. The value of 8.4 is also transmitted instantly. Let's enter a large number into the long values. When I send the long value, the instantly, we can follow that it is transmitted as. We can follow that it is transmitted as. Let's test sending binary value command. When we press the button, let's see that the value of the expression we gave is 1. As you can see, a value has been written here. Let me pull it back to 0. Let's send it again. When I send it, I put a value here as a command. Let's right-click for the word writing command and enter a value. We entered the value 247 times is transmitted here instantly. Let's write a different value again. I wrote a value like 321. That has been sent here. Now, let's enter a value for float. A value like 10.47 here. I entered. We saw that the value 10.47 was passed here. Again, we can enter a large value into the long register. When we enter this value here, the command is sent instantly in the long write section. In this way, you can follow the transactions with watching online view. With the Export Table to Excel option, we can define variables in bulk via Excel. For this, Export to Table, I also click and select Location. When we open the Excel template, rows and columns, we can see what is in the definitions. Again, we can make a selection from here. In this way, you can create it from scratch here. The point to be considered while defining is the line label. The line labels of the variables in the project are exactly the same as an Excel definition is required. I'm creating a command to write a binary input. Let's name it binary write2. Also give the line label name binary write2. Let's pull these down like this. I'm defining the address as 8. There will be a control relay here. Let's make the other definitions the same as the previous definitions. Let's save it. For binary write2 command definition, let's add a new binary register. Let's save the definition we made for binary write2. In the project section, import data from Excel. Let's select the Excel file we created from the Excel option. The preview will appear on the screen. Let's continue by clicking OK. A warning appeared on the screen. It says these names are not used because they're already defined labels. Let's say OK and close the warning. The last line we added has been added to the variable address table. In this way, you can transfer DNP3 protocol definitions from the Excel file.